First is if two spheres are identical. If two spheres are identical, having charge q1, q2, if two spheres are identical, when they are brought together and separated. Then charge on each will be q1 dash equals to total charge upon 2, and q2 dash is also total charge upon 2. If sphere A has radius r1 and sphere B has radius r2, if they are connected by wire or touch together, then charge on first one will be r1 upon r1 plus r2 of total charge, and charge on second will be r2 upon r1 plus r2 of total charge. Write this too. This is based on law of conservation of charges.
Done, sir.
Completed?
Yes, sir.
Yes, sir.
Third, if two capacitors having capacity C1, C2 charged by charge up to Q1, Q2 if connected together. Then after connection, Q1 dash will be C1 upon C1 plus C2 of total charge, and Q2 dash will be C2 upon C1 plus C2 of total charge. Then one very basic, since charges are quantized, therefore total charge is always plus or minus of integral multiple of charge of electron. Positive when lost and negative when gained. Positive when electrons are lost. Negative when electrons are gained. Yes, written this also.
Yes, sir.
So for charge distribution, see, either it will be half of total or R1 upon R1 plus R2 of total, or R2 upon. Same way for capacitor, C1 upon C1 plus C2 into total charge. What is formula for force between two charges in air?
1 upon 4
1 by 4 pi.
Q1 Q2 upon R square.
1 upon 4 pi epsilon naught Q1 Q2 by R square. If two charges are situated in dielectric medium, then 1 upon 4 pi K epsilon naught Q1 Q2 by R square. Force between two charges in medium is Fa upon dielectric constant. Dielectric constant is called also relative permittivity, which is epsilon upon epsilon naught. Epsilon upon epsilon naught. If charge capital Q is split into two charges, charge capital Q is split into two charges, then for maximum force, Q1 is same as Q2 is same as Q by 2. Then if sum of two charges are given and force is given, sum of two charges are given and force is given, then using Coulomb's law, find product of two charges and then find Q1 comma Q2. This 10th wala point followed what I said. They will give sum of two charges is 9. Force is this, distance is this. Suppose by calculation I get product as 20. Then I know Q1 plus Q2 is 9 and Q1 into Q2 is 20. Then using this two, can I simplify to get Q1, Q2?
Yes, sir.
Now write down points till 10th. And if you are done, please keep on telling me. Shashwat, Gargi, you all can hear me? Yes, Shashwat, can you hear? Okay, Gargi. Shashwat? Shashwat saying, can you hear me? Mansi?
Yes, sir.
These are all last minute revision wala points to be remembered before you enter in examination hall.
Done, sir.
Done, sir.
Yes, yes. Sometimes this force we have to find resultant force by vector addition. So when two vectors are in same direction, what is resultant? Yes, two vectors are in addition. Opposite then?
Subtract.
Perpendicular then? Pythagoras theorem. If inclined by any angle then? Parallelogram law. Correct? इतना याद हुआ?
Yes, sir.
तीन स्पेशल केस लिख लो. When two vectors are equal and inclined by 60 degree, then resultant is √3 times given vector. When two vectors are equal and inclined by 120 degree, then resultant is same as given vector. 13th, when two vectors are equal and perpendicular, then resultant is √2 times given vector. Write this 3 point.
Done, sir.
See, net force at centroid, I have written 0 by using this concept. You want me to explain or you followed?
Followed, sir.
Followed, ना? This is F equal ये angle 120 तो result F, एक F ऊपर एक F नीचे 0 आ गया. Everybody has done all the 14? Shall I clear it?
Yes, sir.
Okay. Now actually force related सब कर दिया आपके लिए. खाली आप एक कॉन्सेप्ट समझ लेना. कभी कभी वो लोग बोलेंगे दो स्फीयर अलग था, दोनों के बीच में डिस्टेंस समथिंग सम फोर्स, फिर दोनों को टच करके सेपरेट किया, व्हाट विल बी न्यू फोर्स. तो आपको ये मालूम रहना चाहिए टच करके सेपरेट किया तो चार्जेस क्या आएगा एंड देन टेक रेशियो. फिर वो भी समझा दिया अगर सम दिया है तो प्रोडक्ट ऑफ फोर्स से निकालो. फिर ये भी बता दिया मीडियम में एफ अपॉन के होएगा. रिजल्टेंट दो तीन फोर्स का है तो वेक्टर एडिशन निकालना. अब इंटेंसिटी. What is electric field intensity defined as? Force upon charge due to point charge, or 1 upon 4 pi epsilon naught q by r square. E is also minus of potential gradient. Please copy these three formulas for point charge. Electric potential due electric intensity. Electric field intensity due to electric dipole at any point on axis from E equals to 1 upon 4 pi epsilon naught 2p upon r cube. It is along p bar, that is from negative to positive charge. 17. At equator of electric dipole, E is 1 upon 4 pi epsilon naught p upon r cube. देखो ध्यान से E is here 1 upon r square, इधर 1 upon r cube हो गया. So sometimes they can also say for point charge E is proportional to, it is 1 by r square. For dipole 1 upon r cube. It is opposite to p bar. At any gun electric field due to electric dipole from E equals to 1 upon 4 pi epsilon p upon r cube 3 cos square theta plus 1. Direction is given by tan alpha equals to half tan theta.
Done, sir.
Point charge over electric dipole over. Now we are finding due to linear charges. कौन सा पॉइंट है 80
19.
19. Suppose this is thin conductor of length L and charge is distributed on its body. Then along its axis there is one point P at distance A from nearer end. We want what is intensity. Is K lambda. K means 1 upon 4 pi epsilon 0. 1 upon A minus 1 upon A plus L. Here lambda is total charge upon total length. Draw diagram and write the value. Formula. K is not dielectric constant. It is 1 upon 4 pi epsilon naught.
Does.
What is lambda? Can you tell?
Linear charge
Linear
density.
charge density.
Linear charge density means what upon what?
Q by L.
2 by L.
Total charge upon total length. So if point is on the axis of thin charged conductor, then intensity is 1 upon 4 pi epsilon naught lambda into 1 upon, I have written that as K. So it will be K lambda 1 upon A minus 1 upon A plus L. Next. Electric field at center of semicircular conductor.
20.
Next one, 19th one. Electric field at center of semicircular conductor is given by E equals to 2k lambda by R. 2k lambda by R.
So the above one is 20th point.
Okay. Then electric field at center of half of semicircle. Half of semicircular conductor is given by k lambda by r. In semicircle का half हो गया k lambda by r. This actually it is k lambda by r का root 2 k lambda by r. 22 electric field at center of charged arc subtending angle alpha at center. अब ये सेमी सर्कल हो 1/4 सबके लिए वैलिड हो is given by E equals to 2k lambda by r into sine of half of the angle. That means if it is semicircle, angle is 180, sine 180 upon 2 is sine 90, sine 91, 2k lambda by r. If it is 1/4, then angle is 90. So 90 by 2 is 45, sine 45 is 1 by root 2 k lambda by r.
Done, sir.
Okay. See, this is thin conductor. Point is at any distance perpendicular to the conductor. On the axis वाला हम लोग ने कर लिया k lambda in bracket 1 upon a minus 1 upon a plus a. But if it is on the thin straight conductor perpendicular distance, then there are two values. One is called E perpendicular, that means E along y direction. Like this is the point. If you consider elemental length here, then it will have two components. One will be Ex, other will be Ey. Y is called E parallel, Ex is called perpendicular. So two formulas we have to find. एकदम पेपर डिफिकल्ट होगा तो ये आएगा E perpendicular and E parallel. Perpendicular means okay, आप ऐसे याद रखना because sometimes it will be horizontal given then perpendicular will become y axis. E perpendicular is for finite conductor E perpendicular k lambda by perpendicular distance a is sine of theta 1 plus sine theta 2, somewhat similar to our magnetic field near finite conductor. This is k lambda by a cos of theta 2 minus cos of theta 1, right? Perpendicular and parallel form. a finite conductor, a point is close to it, then electric field is given by. Yes, shall I clear this now? Done?
Yes.
Yes, sir.
Answer number 24 then, eh?
Yes.
Electric field at any point on the axis of charge ring. Electric field at any point on axis of charge ring. At any point on the axis of charge ring. This is R, X. This distance is R. Point is on the axis. So E is equals to K Q X upon R square plus X square raised to 3 pi. Generally, this type of sums they will give you ratio basis or something. At any point on axis, kqx upon r square plus x square raised to 3 pi. At center, x is 0, so e will become 0. At infinity, also e is 0, because anything upon infinity is 0. So whenever ring at center and at infinity, e is 0. Completed?
Yes, sir.
Intensity at any point outside charged sphere. When I say charged sphere, means it can be hollow, conducting, or hollow, non-conducting, or solid conducting. So first, at outside, E equals to 1 upon 4 pi epsilon q by r square. On surface, E equals to 1 upon 4 pi epsilon q by capital R square. At any point inside, E equal to 0. Three formulas. Outside, on the surface, inside.
Done.
Intensity at intensity for non-conducting sphere. Non-conducting. That means charge lies inside, not on the surface. Throughout inside. So first, for outside point, same formula. 1 upon 4 pi epsilon naught q by r square. But generally in this case, they will give charge per unit volume as rho. So volume you can write 4 by 3 pi r cube into rho, substitute for that. For surface, E is 1 upon 4 pi epsilon naught q by capital R square. At inside here E is not 0. E is given by 1 upon 4 pi epsilon naught q r small r upon r cube. So point is inside, then E you can see it is proportional to R. Outside, inversely proportional to R square. Copy this 3 point. This is very important. QR upon capital R.
Done, sir.
Intensity near long infinite wire or charge cylinder equals to lambda upon 2 pi r k 2 pi r epsilon naught, where lambda is charge per unit length. 28. Intensity for solid non-conducting cylinder. Whenever only cylinder means it is hollow conducting or hollow non-conducting or solid conducting. Here outside and surface formula doesn't changes. That means it will remain same, lambda upon 2 pi r epsilon naught. On surface, E will become lambda upon 2 pi capital R into epsilon naught. So inside formula changes. So whenever paper is difficult, they may ask you for non-conducting solid cylinder. On surface same, outside it is same, only inside it keeps on changing. Hello? Hello? So inside it is
Yes, sir.
rho r upon 2 epsilon naught, rho is charge upon volume. ये खाली inside वाला formula ध्यान से देखो, it is directly proportional दोनों केस में, whereas बाकी सब में रहेगा तो inverse आता है. Copy.
Sir,
Hmm?
so the third point is rho r upon 2 epsilon naught, na?
Correct.
Okay, sir. Done, sir.
Intensity at any point near infinite plane charge sheet equals to sigma upon 2 epsilon naught. Intensity near charged conductor of any shape equals to sigma upon epsilon naught. Yes, copy this one. Electric flux is integration of E bar dot ds bar by Gauss's law. Flux phi is q inside charged surface upon epsilon. Completed?
Yes, sir.
Yes.
Total normal electric induction E dot N dot E dot I is epsilon times flux. That is same as epsilon times charge inside the closed surface upon epsilon naught. So it is nothing but charge enclosed. एक नया term, total normal electric induction is charge enclosed by the surface, right?
Done, sir.
Torque experienced by electric dipole when placed in uniform electric field, comma equals to tau equals to Pe sin theta. E means Q into 2A or 2L, which is called as electric dipole moment. For minimum torque, theta equals to 0 or theta equals to 180. For maximum torque, theta equal to 90 degree. Therefore, maximum torque is E. Okay. Done.
Yes, sir.
So, when torque is 0, the condition is called as equilibrium condition. But for theta equals to 0, it is stable equilibrium. For theta equal to 180, it is unstable equilibrium. Potential energy of dipole, comma, U equals to E cos of theta 0 minus cos theta. Theta 0 is initial position. Theta is final position. Copy 38, 39.
Done, sir.
Electric,
So 40.
electric potential due to point charge at distance r is V equals to 1 upon 4 pi epsilon naught Q by R. For electric dipole, V equals to 1 upon 4 pi epsilon naught P cos theta upon V square R square. V at any point on axis is plus or minus P upon 4 pi epsilon naught R square plus for closer to positive charge. The equator is 0.
Done, sir.
Electric potential for sphere at outside V equals to 1 upon 4 pi epsilon naught Q by R. On surface V equals to 1 upon 4 pi epsilon Q by capital R. Inside V is same as that of surface. That is V equals to 1 upon 4 pi epsilon naught Q by R. 45th है क्या ये?
44.
44th.
Electric potential for solid non-conducting sphere. बेटा
Yes.
this two same. Just copy.
Done.
Inside वाला special form. At any point
So inside. Okay.
equals to first same as that of surface 1 upon 4 pi q by r bracket में याद रखना that is 3 by 2 minus r square upon 2 times capital R. Right. Written?
Yes, sir.
Relation between E and B. First E equals to B upon
36.
E equals to B upon D. Second E is minus BB upon D. It's E is function of x, y, z. Then Ex is partial derivative with respect to x. Partial मतलब खाली x variable होगा, बाकी constant. Then y variable होगा, बाकी constant. Ez will be minus dv upon dz. E bar will become ex I cap plus ey j cap plus ez k cap. Done?
Yes, sir.
So, potential surface. The surface on which potential remains same is called as equipotential surface. For point charge, equipotential surface will be spheres. These are equipotential surfaces. For linear charge, cylinder is equipotential surface. For linear charge. For two parallel plate, one positive, one negative. This is electric field. Then this one is our equipotential surface. Right, and draw the diagram to this.
I didn't get the third diagram.
Third diagram, equipotential surface, two parallel plate. Field is from positive to negative. Equipotential is perpendicular.
Okay.
हेलो, अरे पागल पागल हो गया, दिमाग है क्या है थोड़ा? वो वही चीज उसमें दिया है ना पहले, फिर से वही पूछ रहे हो? दूसरा कुछ मिल नहीं रहा है क्या? चैंपियन में अपना पास स्ट्रीट में पहले 1 से लेके 40 में इतने सम्स हैं, बार बार उधर गोल गोल घूमते रहते हो क्या? इतनी बार बोल रहा हूँ कैपेसिटेंस और छोड़ के है, बाकी तो कुछ भी पागल जैसा काम कर रहे हैं। एक ही तो देने का है खाली, उसमें से 14 निकाल के खाली टाइम पास चालू है। सुबह से आप 10 बजे आए ना, 10 से 12 हो गया, क्या काम हुआ? थोड़ा दिमाग लगा के काम करो और फास्ट करो। ऐसा नहीं खाली कुर्सी पे बैठे रहेंगे और कुर्सी टूट गया उसको अपन चेंज कर रहे हैं और उससे ही बहुत बड़ा काम लग गया। फटाफट करके भेजो ये। Completed?
Yes, sir.
Yes.
1 minute. Can I clear this now?
Yes, sir.
अभी दो चार्ज अगर पॉजिटिव होगा ना, दोनों अगर पॉजिटिव पॉजिटिव और इक्विपोटेंशियल सरफेस आइडेंटिफाई करने को, तो पहले तो इसका इलेक्ट्रिक फील्ड देखना आप। इलेक्ट्रिक फील्ड पॉजिटिव चार्ज के लिए आउटपुट होता है, आउटपुट वैसा इधर आउटपुट, दे विल नेवर इंटरसेक्ट। फिर इक्विपोटेंशियल सरफेस मतलब जहां पे वोल्टेज सेम और वो परपेंडिकुलर टू ये सरफेस कर्व होने वाला है, तो ऐसा है। ऐसा रहेगा सर्कल जैसा। कॉन्सेंट्रिक है, रेडियस अलग रह सकता है, मतलब इट इज नॉट परफेक्टली सर्कुलर, थोड़ा इलिप्टिकल। 49 थे क्या अभी इसके बाद?
Yes, sir.
ऑलवेज याद रखना, इलेक्ट्रिक फील्ड इज परपेंडिकुलर टू इक्विपोटेंशियल सरफेस। मैकेनिकल फोर्स पर यूनिट एरिया ऑन चार्ज कंडक्टर, force upon area is half sigma square upon epsilon naught or half epsilon naught into E square. Yes, completed?
So,
Okay. Now see, formula list only they got 50. हर एक पे एक एक भी सम होगा तो कितना होता है ना ये चैप्टर में? 51. एनर्जी डेंसिटी और एनर्जी stored per unit volume du upon dv is half of same formula or half epsilon naught into E square. Copy 51 also. Have I clear this?
yes, sir.
If charged drop is stationary between electric field, then mg equals to electrical force. So in terms of voltage, you can write V upon T. Copy this also. Except condenser, rest all is completed. Shall I clear?
No, sir, please, sir.
Wait.
Thanks.
Capacity general is Q by V for parallel plate condenser. C equals to A K epsilon naught by D. If medium is air, then K equal to 1. So C will become A epsilon naught by T. Completed?
Yes, sir.
Okay. If
56.
सेंचुरी मारेंगे लगता है आपको. If dielectric slab of thickness T having dielectric constant K is introduced between plates, then C is A epsilon 0 upon D minus T plus T by K. देखिए याद रखना, अगर आ गया तो इजीली ये फॉर्मूला होगा तो 1 मिनट में हो जाएगा. राइट. $56 completed.
Yes,
Yes,
sir.
sir.
Okay, next one, see, if dielectric distance between plate is divided into n parts with dielectric slab of dielectric constant K1, K2 dot 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 up to Kn with thickness T1, T2 dot dot dot, then it behaves as series combination such that C equals to same area, same epsilon, distance is divided into n parts, so d by n inside T1 upon K1, T2 upon K2, dot 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 up to Cn upon Kn. अगर दो ही रहेगा with same thickness, hello?
Yes.
A epsilon naught, suppose we have only two, then it will become d divided into two parts. Thickness is T1 upon T2 plus this. Okay, right, ऐसा. A epsilon से T1 ठीक है बिल्कुल.
Sir, d by n is not there.
No, d by n इसके साथ d by n नहीं. इसका मतलब ये है सर. A1, T1, ये पूरा distance T is divided into n parts. A2, P2, and last one is Kn, Th. ये combination is series combination. One condenser, two condenser, three. चलो क्लियर कर दूं ये?
Yes, sir.
If dielectric divides area then combination is parallel combination such that C is epsilon naught upon D A1 up into K1 plus A2 into K2 dot 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 up to AN Kn. This time thickness is same, area it is divided.
Sir, epsilon or d, no?
Epsilon naught upon D. D सेम है, एप्सिलॉन सेम है, जो चेंज हो रहा है वो ब्रैकेट है. Energy stored between plates of condenser comma U equals to half CV square half QV half of Q square upon C. 68. 1 upon C in series is 1 upon C1 plus 1 upon C2, 1 upon Cn. C parallel is C1 plus C2 up to Cn. When battery is kept connected, then voltage is same. Yes, can I clear this again?
Yes, sir.
Still you are writing?
No, sir.
Read कर दो पूरा.
Yes.
63. When battery is disconnected, then charge remains same. 54. For like plates, short form में लिखा like plates connected together. Common potential V equals to C1 V1 plus C2 V2 upon C1 plus C2. For unlike plates connected together, common potential is C1 V1 for difference with C2 V2 upon C1 plus C2. So I have completed almost all synopsis. Please first revise formula, then start solving numericals.
Done, sir.
बस फिर आज के लिए इतना पूरा कंप्लीट करना. नेक्स्ट क्लास आई विल सॉल्व MCQs based on this.